Hello, in our Insight this week we're continuing with our mini-series on pre-emergent herbicides. So let's recap. In episode 1 we learnt where Roberto Buzzi, he evolved Sakura resistance in the lab using recurrent selection of Sakura on some nasty ryegrass, evolved Sakura resistance in the lab, and then also found that it was cross-resistant to Boxer Gold and Avidex. In episode 2, he teamed up with Todd Gaines and Martin Villa-Ayoub and found that this was semi-dominance at play for the inheritance of these genes, and there's a single gene that codes for resistance. And then also that this resistance can happen in both directions. Now in episode 3, Roberto is trying to use what he's learnt from the previous studies and other previous research to see if he can reverse some of this resistance in the lab. So what he did was picked up on some old work where malathion was used. It's an insecticide. It switches off P450 enzymes and then stops metabolic resistance. So in this case, he used a different insecticide called Phorate. Phorate is not registered in most of our crops, so we don't recommend it, but it was just used for the purpose of the research. Roberto sprinkled some Phorate on his pots, then put in his seeds and his trifluralin. So he has a trifluralin resistant ryegrass population. The dose response curve looks like this compared to a susceptible. Now where Phorate was sprinkled on the pots before applying the herbicide and the seeds, he created a dose response curve that looked like that. In other words, it almost completely reversed the resistance. So it looks like this trifluralin resistance is metabolic, and that using an organophosphate insecticide can potentially switch off that resistance. It worked a little bit for Sakura and for chlorsulfuron, but it actually caused the opposite effect for Boxer Gold and Avidex, and we'll tell you more about that if you tune in to RE Insight.